Welcome everybody. Today we're going to start on with our collision detection of two lines. Now in order to start the collision detection between two lines, we need to first understand one of the important points of mathematical geometry, which is to find the shortest distance between a point to a line. Now in our GPRG, we are only interested into the aspects. So treat it like as if you are doing it on a graph paper. And with that, you have a point and a line. And you want to find the shortest distance between a point to a line. So I've come up with a slide to denote the summary of finding a point that is finding the distance between a point and a line. So I'm going to go through the whole full understanding of this using a whiteboard. So given a whiteboard like this, and you have a point, say here. This point is known as, say, in our case, what do we do here? We just call these things a point, which is down here. All right, so we didn't give any name. All right, let me give it a name C then. All right, so we have a point, say down here C. Now C itself has x and y coordinates. Now next I have a line, say from here. The line has a point A having the coordinate x1, y1, and a point B here having a coordinate x2, y2. Now what we want here is we want to find the shortest distance between the point and the line. Now mathematically, the shortest distance between a point and a line is actually the perpendicular distance that the line forms with the point. So in this case is the green line that I draw here. Now in order to make things simpler, okay, we draw a line from the starting point here. Now with that, this perpendicular line, we were going to call it Z vector, right? And the line here, we're going to call it A vectors, all right? And the line which is on the other side here, we're going to call it B. All right, so let's write down all the coordinates for both A and B at the side here. So A is simply CA or AC, doesn't matter the direction. So in this case, it is actually OA minus OC, okay, which is your x1 minus x, comma y1 minus y. So given a point and a line, this portion is definitely known. Okay, we definitely know this point. Okay, now next we need to find Z. But before we find Z, let's find B first. B is simply a B, which is OB minus OA. So in this case, it is actually x2 minus x1, comma y2 minus y1. And we know this as well. Okay, so far so good. Next, we need to find Z. Z is simply the perpendicular of B. Okay, which means to say we need to switch the x and the y around and put a minus in one of the coordinates inside here. So, which is this. So it's y2 minus y1, comma, then it is the negative of x2 minus x1. So simplifying, we get y2 minus y1, x1 minus x2. Okay, and we will know this as well. Now, if you have do it carefully and if you take a look here, what the distance of the z here, which is this z magnitude. Okay, so we should be able to find. So far we only know the direction of z, but we do not know the magnitude of actually through z itself. All right. So we know the unit vector of z. Okay. If we know the unit vector of b, let's say. All right. So the unit vectors of b is basically equals to this b unit vector of b is simply equals to b divided by magnitude of b, and we know the magnitude of b. Magnitude of b is basically the Pythagoras theorem, which is here. Magnitude of b is equals to square root of x2 minus x1 square plus y2 minus y1 square. All right, and we know this as well. So we know the unit vector z here. Now, z here under the cosine, you know that, okay, opposite, if we have a theta here, then cosine theta is equals to adjacent over hypotenuse. Okay, so in this case, it's magnitude of z over magnitude of a. We definitely know magnitude of a. All right, so our z here is equal to a cosine theta. Now, how do we find cosine theta? Cosine theta is actually come from this. Okay, now we can write this. Since z is unit vector 1, so we can write a z unit vector. This is cosine theta. Now this itself is a dot unit vector z. Okay, and we know a and we know z. So now we just need to perform a dot product. Now in Emacs, you know that in matrices, if I have 1, 2 dot 3, 4, what is it? It is 1 times 3 plus 2 times 4. This process is actually your dot product, and it is applied down here. Okay, we know the coordinates a and we know the coordinate of z. So, and then we apply a dot z, a dot unit vector z inside here to get our unit, our length for z. Okay, now the last part to take note is if we were to use this one to dot it here. Now, if the point lie on one side of the curve is positive, then if there's a point down here and we dot the same thing, this part will be negative. Alright, this is very important later when we want to find whether the two lines does intersect or not. Alright, for now, this is it. So just a recap, what we want to find is the shortest distance between a point and a line. The shortest distance between a point and a line is given by the perpendicular distance here. Here. Alright, in order to do that, we take the unit vectors of this and dot with the vector A, which is the distance between, or rather the displacement between the point and either one point in the line. Now, the unit vector z can be derived by taking the perpendicular of the line AB. This is done by interchanging the x-coordinate with the y-coordinates and substituting one of them with a negative down here. So once this is done, we are able to determine the distance, the shortest distance between a point and a line. Thanks for watching.